I thank you all for watching my videos. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem that appeared in the CSIR National Eligibility Test held in the month of June 2023. And the question is from the section Analysis, and it is related to the convergence of a given real series. The question is from the part B, which is a multiple choice question, and it carries 3 marks. The question ID is 704022. This question is suitable for the aspirants of all these examinations. Right. The given question is, consider the series sigma n is equal to 1 to infinity a suffix n, where a n is equal to minus 1 to the power of n plus 1 into, in brackets, under the square root of n plus 1 minus under the square root of n. Which of the following statement is true? We are given 4 options. Option 1, the series is divergent. Option 2, the series is convergent. Option 3, the series is conditionally convergent. Option 4, the series is absolutely convergent. Let's now discuss the solution of this problem in detail. We are given the series sigma n is equal to 1 to infinity a n, where a suffix n is equal to minus 1 to the power of n plus 1 into, in brackets, under the square root of n plus 1 minus under the square root of n. Agreed. Now, let us now write sigma n is equal to 1 to infinity a n as sigma n is equal to 1 to infinity minus 1 to the power of n plus 1 into bn, where b suffix n will be under the square root of n plus 1 minus under the square root of n. Note down now, bn is greater than or equal to 0 for all n, and it is in fact bn is positive for all n greater than or equal to 1. That means for all n belongs to n. Note that bn is positive greater than 0 for all n belongs to n. And it is an alternating series, obviously. So for the convergence, we have to think of the test for alternating series, that is Leibniz test, that I will show you in the course of time. Now, bn is under the square root of n plus 1 minus under the square root of n. Now, we rationalize the numerator, this one, by multiplying by root of n plus 1, multiplying and dividing by root of n plus 1 plus under the square root of n. So we multiply and divide by that. Now when we take the numerator, the product is a plus b into a minus b, that is a square minus b square. Then you will get n plus 1 minus n by under the square root of n plus 1 plus under the square root of n. And in the numerator, n and n cancels, and you are left with 1 in the numerator. That is equal to 1 by under the square root of n plus 1 plus under the square root of n. Agreed. Now we recall the alternating series test, the so-called Leibniz test. You all know that the alternating series sigma n is equal to 1 to infinity minus 1 to the power of n plus 1 into an, where an greater than or equal to 0 for all n belongs to n, is convergent if the following two conditions are satisfied. Limit n to first condition, limit n tends to infinity of an is 0. The second condition, the sequence an is a monotonically decreasing sequence, that is an plus 1 is less than or equal to an for all n belongs to n. If these two conditions are satisfied, then it is convergent. In our case, it is minus 1 to the power of n plus 1 into bn we have considered. So, limit n tends to infinity of bn is limit n tends to infinity of 1 by root of n plus 1 plus root of n plus root of n is equal to 0, obviously. The first condition is satisfied. Now, clearly, root of n plus 2 is greater than root of n plus 1. Root of n plus 1 is greater than root n. Therefore, root of n plus 2 plus root of n plus 1 is greater than or equal to root of n plus 1 plus root of n. Now, taking the reciprocals on both sides, then it will be 1 by root of n plus 2 plus root of n plus 1 is less than or equal to, yes, it is greater than or equal to here, therefore it is less than or equal to 1 by root of n plus 1 plus root of n for all n belongs to the set of natural numbers. Agreed. What is this one? It is bn plus 1 is less than or equal to, it is bn. So, this implies bn plus 1 is less than or equal to bn for all n belongs to n, that is bn, the sequence bn is a monotonically decreasing sequence. The second condition is also satisfied. By Leibniz test, the given series, that is sigma n is equal to 1 to infinity minus 1 to the power of n plus minus 1 to the power of n plus 1 into bn is convergent. That is same as sigma n is equal to 1 to infinity an is convergent. Now let's call our options. Option 1 says the series is divergent. No, it is convergent. Therefore, option 1 is not true. Option 2 is the series is convergent. Yes, it is convergent. Therefore, option 2 is true. So, we get option 1 is not true and option 2 is true. Right. Now, we continue our discussion in the next slide. Right. Now, we talk about absolute convergence because in option 3 and 4, in option 3, it is conditional convergence. In option 4, it talks about absolute convergence. So in both of the cases, the absolute convergence is needed. Therefore, we discuss the absolute convergence of the given series sigma an. So, sigma n is equal to 1 to infinity mod an is equal to sigma n is equal to 1 to infinity mod of an is minus 1 to the power of n plus 1 into bn. When you take the modulus, it will be sigma n is equal to 1 to infinity bn because bn's are positive. Right. Right. So now bn is what? Bn is 1 by root of n plus 1 plus root of n, which you can see 1 by root of n plus 1 is less than or equal to 1 by root n. 1 by root n is equal to 1 by root n. So, 1 by root of n plus 1 plus root of n is less than or equal to 1 by 2 times root of n, which is less than 1 by root of n. This tells us you have to consider the auxiliary series as 1 by root n. So, consider the auxiliary series sigma n is equal to 1 to infinity Cn, where Cn is 1 by root n. Now, we apply limit comparison test. So, now limit n tends to infinity bn by Cn is equal to limit n tends to infinity bn 1 by root of n plus 1 plus root of n into by Cn is root n by 1. Now, limit n tends to infinity root n by, we have taken root n common in the denominator, that is root n into under the square root of 1 plus 1 by n plus root n. So, root n cancels both numerator and denominator, and taking the limits as n tends to infinity, we will get 1 by 2, which is non-zero and finite. So, by limit comparison test, the two series sigma bn and sigma cn either both converge or both diverge. Now take the auxiliary series Cn 1 by root n. Then sigma Cn is divergent by P series test. Here sigma Cn is sigma 1 by root n is divergent by P series test, because 1 by root n means 1 by n to the power of P. P is 1 by 2. 1 by 2 less than 1. Therefore, it is divergent. So recall, a P series sigma 1 by n to the power of P converges if and only if P greater than 1. Here P is 1 by 2 less than 1. Therefore, it is divergent. So sigma Bn is also divergent. So therefore, sigma n is equal to 1 to infinity Bn is divergent. That means sigma n is equal to 1 to infinity mod An is divergent. That means sigma n is equal to 1 to infinity An is not absolutely convergent. Is not absolutely convergent. Right. So thus sigma An is convergent, which we have seen under option 2. And now we have seen sigma n is equal to 1 to mod An is divergent. Sigma n is convergent. Sigma mod An is divergent. Therefore, the series sigma n is equal to 1 to infinity An is conditionally convergent. This alternating series is conditionally convergent. So let's look at our options. Option 3 says the series is conditionally convergent. Yes, it is true. Option 4, the series is absolutely convergent. Series 3 says it is conditionally convergent. Yes, option 3 is true. And option 4 says the series is absolutely convergent. No, absolutely it is not convergent. It is not convergent. Thus, the option 4 is not true and the option 3 is true. Therefore, the answer to this question is options 2 and 3. We got a question marks, 3 question marks. How it is? What do you mean by these 3 question marks? It is a question given under part B, which is a multiple choice question for 3 marks. And where we are supposed to have only one correct answer. But both these options are coming out to be correct. That is why these 3 question marks have come. So if you give any one of these 2 answers, that is option 2 or option 3, I hope that you will be awarded full marks. Any one of these options. So that is the detailed discussion of the solution of this problem from the section analysis. It is related to convergence of a given series of real numbers. I am sure that you have understood the solution of this problem. I thank you all for watching this video. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. We shall meet once again in another episode of learning. I wish you all the best. Thank you.